The distance between two consecutive points in phase is the wavelength, lambda, of a wave. Here you can see points R and S moving in phase with each other, and so they are one wavelength apart. Now for the next description. The maximum displacement of a particle from the rest position. The maximum displacement of a particle from the rest position to the top of the crest, or from the rest position to the bottom of the trough, is the amplitude of the wave. The symbol for amplitude is capital A. Do you recall what we call the time taken for one complete cycle or oscillation? One complete cycle or oscillation is the movement of a particle from the rest position to the top of the crest, then down to the bottom of a trough, and then back to the rest position. The time taken for one cycle is called the period of the wave. The symbol for period is capital T and is measured in seconds. We can write an equation for period as T equals the time taken divided by the number of cycles. A pulse lasts for one period, but a wave consists of a series of pulses. So when dealing with waves, we need to measure the number of cycles or pulses produced in 1 second. Can you remember what we call this concept? Well, the number of cycles per second is called the frequency of a wave and is measured in hertz. By looking at the equations for period and frequency, you should be able to see that frequency is the reciprocal of period. In other words, we can write either F equals 1 over T or T equals 1 over F. There's one more term we need to examine: the speed of the wave, v. To calculate the speed of a wave, we can multiply the frequency by the wavelength.